Hello everyone, good day. Today we are going to see the course called Sensors and Transducers. The course code given to us is U21ME404. The unit 1 talks about basics of measurement, classification of errors, error analysis, static and dynamic characteristics of transducers, performance measures, and the classification of sensors, some calibration techniques of those sensors and output signal types. Right. So while getting into the unit number 1, that is the introduction topic. In a general view, the term mechatronics is combination of mechanical, digital control system, electronics, and electromechanical systems. So basically, the core thing which comes under this mechatronic system is all about mechanical, electronic control and computer systems. The area of application extends to automotive, aerospace, medical, and some manufacturing, material processing. In almost everywhere the application of sensors and transducers have been rooted in. So what is the mechatronic system approach of this sensors and transducers course is all about? If you take any mechatronic system, that consists of basically of three types or three units, you can say. Number one is mechanical system, and then you have your processor, and finally you'll be having some output unit. Talking about mechanical systems, you can see these actuators and sensors where you can get the actual work of that particular mechanical element that can be sensed through a sensor that gives us some feedback to the input control, or you can say the processing unit, that will be again passed on to digital control architectures, where you can see the number of logical functions being performed with the help of some user interface. Like we can give some commands over the measured input or the sensed feedback signal, so that will give us the output signal. Finally, that corrected output signal will be given to actuator in order to move with the new or corrected value of actuation. So this is how a mechatronic system works. So before getting into those kind of applications, we must ensure that what is a sensor could be. So sensor can be a device which detects or measures the physical property from the environment and records, indicates, in other words you can say, which responds to the physical quantities change. Again, you have to be careful that a sensor is not an converting element, it's just a detector or measurement element, so that it just measures the value and just passes the signal to the next instrument, that is called transducer. You can see here transducer is a device that which actually converts the variation into physical quantity such as pressure or brightness into an electrical signal and vice versa. So if at all you want to change the measured signal or the value into some sort of electrical signal which you could see as an output in the electronic device or electrical system, you definitely will be in need of some this sort of instrument called transducer. So basically sensor is a measuring device and transducer is the a device which converts that measured signal into an electrical signal, right? And here comes the measurement system, which contains basically of three parts, which you could see here. Fundamental parts of a measurement system composed of three components. One is transducer, signal processor, and a recorder. As you could see here, the transducer, just now we have seen, it actually converts the measured signal into an electrical form. So physical quantity can be converted into an electrical form, and that signal again can be processed over the signal processor, and finally the recorder or the output unit can give you the processed output. So this is how any measurement system works. We could see some of the this is what we discussed so far, some of the examples of a measurement system. If we take a thermometer for an example, which is shown here, what could be the input for the thermometer? Yes, of course, if you want to check your body temperature, so that temperature being measured on your body, that will be given as an input. So the terminal that you could see here, this will be considered as your sensor or a transducer, which actually detects the physical change, and it gives that signal into the signal processing unit, where this measured signal will be converted to electrical signal, or it can be amplified into the way in which it can be seen over your display. um, so that is what we actually see as a body temperature, for example 97.9 or 100, whatever it is. So this is what happens really. So there will be a thermocouple that actually measures it, and in your inside your processor you could see the amplifier. That's what we said. It amplifies your signal, and it converts some sort of analog signal into digital. That is what A by D converter that actually converts your analog into digital. By that way you can see, or you can get your measured signal physical quantity, that is the temperature, in terms of a binary number, right? So the next example you could see is water floating system, or water tank level indicator, you could say. We could often evidence this sort of mechanical floating based measurement system in our bath room flush tank. You could see when you open that lid of your flush tank, you could see this sort of a float which is attached to a pivot, where this is what the level of water filled in. As the level of the water increases, this ball floating in will get raised up, so that the needle attached to it, kind of arrow, will create some change in resistance over this resistor. So that change in resistance will give us the um, change in level of the water, which is inside your flush tank, you could say. So this is a kind of a mechanical come electrical system or electronic system. So in this way you can automate your mechanical system, or you can say some IoT enabled mechanical systems. And the next topic, when you talk about measurement systems, wherever any measurement system comes, then there could be some sort of error. So we normally term error as a deviation from the accuracy or correctness. So yes, of course, what is the maximum deviation from the measured value or the actual value that can be termed as an error? What are the errors, types of errors? You could see there are three major types. One is you can see this gross error and random error and systematic error. You can see one by one what is it. So gross error can be possible only due to the fatigue or careless nature of the operator, you could say. So they are non-determinant in nature, because when an employee is given a routine job, he has used to do that same job again and again. Over the period of time, he is getting some cyclic load, which we used to call as a fatigue load. So this is called some sort of mental fatigue, and there may be a chance of committing mistakes. So those sort of errors can be termed as gross errors. And for example, incorrect reading of an instrument. Over a period of time, he is reading the same sort of instruments, and he used to do with the same set of equipments to be measured. So there may be chance of reading incorrect value, and incorrect recording of an experimental data, incorrect use of instruments, reading on a wrong scale. These are all possible causes of the gross. When you come back to the random error, this happens only due to the unexpected changes in the conditions, the working environment. When there is a change in your power supply, fluctuation happens, then that will be the major role, that plays a major role in committing these sort of random errors. So we can have some sort of control over this, but we cannot complete it. We cannot control this completely unless we have a foolproof system. I mean, foolproof system, right? So when you talk about random error, as I said, this is not determinant, and it can be done by repeating your experiments. Means you can reduce the error by increasing the number of experiments, that we can call it as a resolution, right? Resolution of instruments can be improved, so that you can reduce your error. And this is about a systematic error in the final one, and this is due to the uh, over usage of the system. When you use the similar system for over a period of say about 5 to 10 years, then that instrument will definitely have undergone some sort of wear and tear. So that will cause this sort of systematic error. They are classified into connection and instrumental error. When you connect those instruments, they may not get in contact with each other, may get in contact with the components very appropriately, so that makes some error. An instrumental error, the instrument itself, it has some sort of error, so that you can not able to control all those systematic errors. So this is what you've seen. And the next topic of the day is all about the control system. Right, so far we have seen a system, which means a system should have a processing unit and an input. So after processing it, it should give some output. So this is what a system. And we have seen a measurement system, which consists of a transducer, processing system, processing unit, and your display. That is what your recorder is all about. When you talk about some control system in mechatronics, that refers to a group of component connected in such a manner to command, direct, or regulate itself or some other systems. Means what? It is a kind of a system. It has to have some sort of control over that process. So if that is the case, then you can call that as a control system. For example, there are two such type of control system. One is a open loop control system and a closed loop control system. As the name indicates, open loop control system, you doesn't have any sort of feedback mechanism in that particular system. Means what? If you give some input, it processes that input and gives you the output. Means you don't have any control over the output produced. Example, switching a light or a fan. So if you switch a light, that will glow. If you switch on a fan, that will rotate. Okay, so this is what a kind of open loop control system. So what about a closed loop control system? When you talk about closed loop control system, you will definitely have some sort of your intervention on the output that is being produced. Means the output can be measured, and some part of your output, or the part of your output can be sensed, and that can be given as a signal to the input measuring instrument. So that error, or you could say that reading, or that the signal can be amplified or corrected. So that corrected signal will be given back to the system, and you can get the corrected value of new input to the processing unit that processes that value and gives you the perfect output. So this is how a control system works. So basic elements of open loop system, as we said, so you'll be having input and some of your processing element, and you'll be having your output. So in processing element, you can see there are control elements and correction units. So these two can be combined together and called as a control unit. And finally you have a processing unit. Okay, this is simplex. This example we just know seen, right? Switching a light, on the output you don't have any control, so it comes under the open loop control system. Other example: bread toaster, electric fan switch, washing machine, TV remote, and electric hand dryer. Now you can see about the basic elements of a closed loop control system. The basic difference between the previous one, that is a open loop control system, and this closed loop control system is this particular element, which is your feedback unit. There is a measurement element. You can see the basic elements of a closed loop system clearly here, right? Control element, correction element, which are the part and part of controller, processing element, and your output. So before getting your output, or while getting your output, you could sense some sort of your output signal through a measurement element, which is nothing but your transducer. Measuring element is your sensor, and that converts that signal into some form of electrical signal with the help of a transducer. So that transducer gives a signal to the correction element, comparison element. This comparison element compares the new signal that is coming out of your output with your reference value or the set value, and it gives the new value to the control element. So this is how the closed loop control system works, right? You could see when you compare it to the other human being, your eyes and brains are your control elements, actually comparison elements, which can sense the distance of the vehicle which is running in front of you, and legs and hands are your control element, vehicle is the actually processing element, and the speedometer is actually the sensor which senses and gives us the feedback. No, you are going closer to the previous one, the car which is in front of you, so you have to reduce your speed, or you can take the right lane so you can go fast as well. So this is how it works. Another example, automatic heater coil. You could see when you switch on this one, then power goes in, heating coil gets heated up, it gives heat, it checks the closed loop control system sensor, checks it with the help of thermostat, which is a temp transducer. It checks the temperature value with the set value so that it compares whether it is lesser or higher than that one. So obviously it changes on its own. This is how the closed loop control system works. Again, the similar sort happens in a refrigerator system. Instead of heating, here the cooling happens with respect to the temperature maintained inside your refrigerator. Another example is automatic electric iron. Of course, when we set some mode like silk, cotton, wool, and it sets the temperature and it allows the voltage to pass on to it till the temperature. Once it is getting reached to that temperature, it automatically cuts down the power supply so that it is not getting heated up further. So that is how it works. And air conditioner, as we know, there is a basic difference between air cooler and air conditioner. So air cooler is something which actually cools the air, whereas conditioner, you can use it for cooling the environment as well as heating the environment. That is what conditioner is all about. And cruise control, so in the recent cars you can see this sort of cruise control option. You can enable it by setting some sort of speeding for about 80, for example 80 speed you could set. So this is set for a certain period until unless you apply the brake next time. So this is how it works, an automatic driving car which runs with the help of ADAS technology, which is advanced driver assistance system. Many of the cars running on road today are implementing this technology. Mahindra XUV 700, you could see this is already been implemented, and they claim that as a self-driving car or autonomous driving car, and you could evidence that one also. Again, this is some sort of automatic tank level monitoring system. We have seen this one, and the shaft speed control, the same sort of example. And once after seeing all these measurement system and control system, now we are going to see something about sequential control system. So by this time you all know what is a control system is all about, and now you have to know what is a sequential control system, in what way it differs from the previously discussed control system. As the name indicates, any control system to that matter which runs on particular sequence, okay, certain sequence, you can say that as a sequential control system. The best example of this particular system is your washing machine, because we can set mode right in your washing machine. Say for an example, if you set some fuzzy logic mode or some speedy mode, based on the input that we give, the washing machine controller, the microcontroller works based on the input that we give, and based on the temperature we set, and it works for that particular period of time, for about 15 to 20 minutes of time or 40 minutes of time. So this is what the sequential control system. Not only that control, it should also have the control over the sequence. What are the sequences to be taken care of? Let us look at here. So this is what the input device, we set our mode here. The timer starts when the moment you give that input, and based on that the program is being set. Sequential control unit was this one. So initially what happens, it activates the machine driver, it switches on the pump, means water pump, it switches on, and once it switches on, the heater is being enabled, and the motor, once ensuring all these things being done, the motor gets activated so that the washing machine drum is ready to rotate. When you put all your clothes inside, it ensures all these things being done already, so then the washing machine is ready to operate. So what are the things being checked as an output signal? Yes, of course, when the pump is switched on, it has to measure the water level is being certain, the required amount of water level is being set or not. Yes, it is set, and door closed or open, that can be checked using the valve opening and closing movement. Heater, the water temperature is being checked, and the motor, the drum speed is checked with the help of speed sensor, temperature sensor, and then position sensor and water level sensor. So these things are being set by this program itself when you choose PD mode or whatever the mode you look for, and these things are happening step by step as a procedure. So that is why it is called a sequential operation control. Fine. Similarly, the automatic film camera happens, right? When you single press your shutter button, the shutter opens and then it sends your IR radiation to the object. That IR radiation, that emits the IR, and it reaches to the object, and it hits the object and return back to the camera, and it senses the distance between the camera and the object. So this is how the object's distance is being measured. So that is why that is how the autofocus is happening. It focuses on the object and it captures the blur free image, right? So this is what some sort of sequence that is to be followed in automatic film camera as well. Yeah, this is what happens. And I think this is what I would like to say about the systems point of view. Then let's move on to some sort of characteristics of a sensor. What are the characteristics to be followed, right? So this is all about static and dynamic characteristics of a sensor or a transducer, you could say. As the name indicates, static characteristics means it has to talk about some sort of non changing things like accuracy or range. Whereas you talk about some dynamic characteristics, it's all about some settling time or cutoff frequency, which is easily changing or which tend to change with respect to time, right? So talk about static characteristics. It talks about range, span, error, and accuracy, and some sort of things will be followed. What is a range? So when you talk something about range, it has to have it has to have two values, one minimum and maximum value. For example, this particular thermometer will have a range of a thermocouple will have a range of 25 to 225. If you say like that, means whenever you call something as a range, you should define with two values, one minimum value and a maximum value. It means what? It can operate between 25 degrees Celsius to 225 degrees Celsius. That is what the range is all about. What about span then? The length, actual allowable or usable temperature within that range is very careful, right? That has to be careful. Within that range is called a span of the temperature value. It means 225 to 25 to 225, right? So you could see here that maximum value is 225, the minimum value is 25. The difference between these two will be 200 degrees Celsius. So the 200 degrees Celsius is going to be your span. Fine. Or if you take some example, this beam is of length 10 meters. If someone says like this, so the length is called as a span of the beam. Whereas if anybody is giving you with some tolerance, for example, this beam can be of 5 to 10 meters length. Means what? The lower value is 5 and the maximum value can be 10 meters, which can be considered as a range of the particular beam. Fine. Error is nothing but your difference between the measured value and the true value that we have seen. Earlier slides also we have seen that this is the deviation from your measured value or the actual value, that correct value, right? Accuracy is how close a given set of measurements to the true value is called accuracy, right? So when you measure some sort of values and how often you are getting very closer to the true value, means the set value or reference value, that is called accuracy. Sensitivity is defined as the ratio of change in output to the change in input. So that is called sensitivity of the instrument. Non-linearity is a kind of a static characteristic. It is defined as the maximum difference from the state. And when you consider this, I think I would like to zoom this up, but no, I don't have control over here. So when you see this, right, this is your linear line and this is your non-linear line. So what is the maximum difference between the straight line and the output plotted between this? This is called the non-linearity error. And drift, when you talk about drift, variation of change in output to the given input for a period of time, over a period of time, is called drift. Means what? When you give some signal through the hardware, it takes some time to give you the output that becomes your, or when you set 5 amps, the output comes with 5.1 or 5.2 amps. That becomes the variation in the output for the given input, which is 5 amps. So that variation can be called as a drift. Okay. Impedance, again the ratio between the voltage and current flow in any sensor, that we know the basic one. And repeatability, it means the how often or how many number of times it will give the same value of measurement, that is called repeatability. Stability is the same output over a period of time. Again, any instrument that has more repeatability will be more stable in nature. That is what we used to say. And resolution is the smallest change in the temperature, smallest change in the sensor that can measure. Normally, whenever we buy some sort of electronic devices like phone, mobile phone, or camera, we also look for the resolution of the camera, right? The smallest pixel, you can say some sort of colloquial terms like pixel, right? That is what smallest change that sensor can detect. And linearity is just about opposite to your nonlinearity. Dead band time, this is what, even after you gave the input, the machine takes some time to give you the output, or for about some 5 to 10 seconds it doesn't respond, it won't respond. That means the machine is dead for some time. That is called dead band or dead time. The range is dead band, the time taken to respond to it is called dead time. Coming back to dynamic characteristics, response time, as I said in the previous slides, it is all about the time. When you consider the property of a sensor with respect to time, then that becomes the dynamic characteristics. Response time, the time taken by the sensor to approach to its true output, means it takes for about 10 to 15 minutes of time to 10 to 15 seconds of its time to reach its original output. Means the sensor's extreme range, then that is what the response time, you could say. And time constant, there is a saying that there is a technical reason that the time taken by the sensor or system to reach 63.2% of its final value, that percentage is given by some technical definitions, so that at least 70%, you could say, of the final output, the time taken to give at least 70% of the output can be called as time constant. Rise time, 90% of the full response, that can be called as rise. So this response time, time constant, rise time are important. And settling time, the time taken by the sensor to be within the close range of a steady state. So whatever the signal that is coming out of the sensor will not have some steady state, right, all the time. So if you want to check whether it is a steady state output, if the sensor is not calibrated very often, so this sensor may offer some sort of non-steady or unsteady value. So this can be called a settling time, the time taken by the sensor to settle all those readings measured, right? Transfer function, a mathematical function that theoretically models the system's output for the each input, means the function, for example, y is equal to mx plus c, that y can be taken as a transfer function with respect to mx and c as a constant. So this is how your transfer function of a sensor is working. And frequency response, the output to the input ratio within the sinusoidal wave. When you consider some waveform, uh, the ratio of output to input within this unit of sinusoidal wave, that can be called as your frequency response. This is what we used to call as frequency, positive and negative sign. So that becomes one single waveform, right? Dynamic error, inability of a system to adequately reconstruct the amplitude of input, that is for dynamic error, because it is always with respect to time. Cutoff frequency, the system response has fallen to -3 decibel of stable output, means what, whenever the sensor is about to fail, about to dead, so this cutoff frequency will happen, right? So with this, I would like to conclude this session, and if you have any further queries, you can ask, or you can leave your comments in the chat box. So thus we can see you in the next video of this lecture where we can see different types of sensors: temperature sensor, motion sensor, displacement sensor, and proximity, and based on the other applications of requirement like